Descartes' rule of signs. Well, we have positive, 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 negative, negative, positive, negative, positive. We see 1, 2, 3, 4 sign changes. That tells us there are 4 or 2 or 0. We start with the number of sign changes we have, and we keep subtracting 2's until we're down to 0, and that will be the number of positive real zeros. As far as the number of negative real zeros, we are going to substitute negative x in for x. Now, when we raise it to the 7th power, we get a negative times the positive 2 in front. That makes that first term negative. The negative to the 6th power is positive times the positive in front makes a positive. A negative to the 5th power is negative times the positive in front makes a negative. Now we're at the 4th power, so a negative to the 4th power is positive times the negative front is positive. A negative to the 3rd power is negative times the negative in front makes positive. A negative squared is positive times the positive in front makes positive. A negative going into the linear term times the negative coefficient makes positive, and then we've got a positive 2 at the end. So there's all the signs of the polynomial. We see 1, 2, 3 sign changes, and that tells us there are 3 or 1 negative real zeros. Doesn't tell you whether they are rational or irrational. It just tells you there will be at least 1, possibly 3, that are negative. And we found that 1 by subtracting 2 away from the 3. Okay, solve this exponential equation. 17 is not a power of 2, so the only way we're going to get that x plus 3 out of the exponent is to log each side. So when we log the left, we get x plus 3 coming down times the log of 2 equals the log of 17 on the right. Now, rather than distribute the log of 2 into the parentheses, I'm going to divide the log of 2 off. That will give me x plus 3 on the left is equal to log of 17 divided by the log of 2. And then I can solve for x very easily by saying x is equal to the log of 17 divided by the log of 2 minus 3. And that is your exact value, and you can find an approximation if you wish to by substituting into your calculator.